Hello everyone, and welcome back to PLC Programming from Scratch. This is Section 4, Programming Fundamentals. And let's make sure you have a good understanding of everything we've covered so far in this course. If you don't, this next section is going to be more than a little challenging. Now we're going to get into a little bit more of the nitty-gritty behind the scenes of making a PLC work, controlling it, setting it up to run, and if you don't already have a solid understanding of what I/O is, what digital is, what analog is, then please go back to the previous sections, review them, and come back to this section whenever you're ready. And assuming that you already are and that you've been paying attention, let's get going. So the first thing we're going to look at is how does a PLC manage its own information, manage its own data internally? When we look at our RS Logix 500 programming environment, on the left, if we go to our navigation pane, under the program files, the next section is data files. And you might imagine that's where we're going to be storing all of the data. When you look at the data files, there are a lot of different options of what type of data the PLC can store. And just to give some idea, when I try to create a new data file, I have the choices of binary, timers, counters, controls, integers, so on and so forth, routing information, extended routing information. And the good news is you are not going to use all of these most of the time. 80% of what you do will be done with 20% of these options. That being said, there will be times when you will need to use some of the other ones, and I'm sure you'll have the opportunity to learn them as you go. For now, we're going to discuss the very basic ones, the ones that we're going to be using day in and day out in our programming lives, and those are binary, integers, and floats. Most of you probably already know the difference between those three, but as this is a novice course, we're going to go ahead and get into that a little bit. So if you want to go ahead and skip a little bit, you can, but I recommend sticking around just as a review if nothing else. I'm looking over into the data files again, and you see I have O0, I have I1, S2, the numbers correspond to the actual file, but the letters give us an idea of what the type is. So when we see B22 and B21 and B9, those are all bits. And bits are what the program uses to store Boolean information. And when you hear expressions Boolean, discrete, digital, those all mean the same thing. 0 or 1. And when we open one of these up, this is what the data table actually looks like. So we have, let's choose a bit, B300. This bit is 0. When we look at B301, right now the value is 1. All of these values will only ever be 0 or 1. That's what a bit is. So, as you might imagine, when we're looking at digital inputs and digital outputs, we're going to be using the bits, the B3s and the B9s and whatever other data files we want to add and create. And if I want to create a B52, I could do it. Not the aircraft, but certainly the data file. When we're looking at analog signals, we're going to be looking at N's and F's. N you might guess, stands for integer. So when we open up this data table, you'll notice our addressing is a little different. It's not B3:0/2. Instead, it's just N7:0, because now we're looking at the word level rather than addressing down to the bit level, but we'll get into that a little bit later. The next thing you might notice is when you look at the data table, you don't have zeros and ones exclusively. Yes, you do still have some 0 values and 1 values. You also have values like 30,000 and 4,993. An integer can handle a much larger value depending whether it's a 16-bit or a 32-bit system. But for most of the numbers that you'll be working with inside of a PLC program that do not have a decimal point, you'll be using integers. For those that do have or do need a decimal point, we're going to be using the F data files, floats. And when you look at the float values, as you probably would have anticipated, you have values like 63.35838. Now we have a lot more precision in a smaller range. So those are the 3 data tables that we're going to be using to store information most frequently. Now, everything you do in RSLogix 500 gets a memory address and a location. So even when we use a timer, we might not be using that timer, we might not think of it as storing information, but the PLC is storing information with a timer. It has to remember how long of a timer it is, when it started counting down, how much time is left, when it's fully counted down, when it's energized. It stores a lot of information. So even timers and things like counters are all going to have their own memory locations assigned.